Welcome back. In this video, we'll be using jump to analyze the relationship between two numeric variables, height and weight. While it might seem obvious that generally taller people weigh more, how strong is this correlation exactly? And does it vary between guys and girls? Welcome back to Teaching Statistical Thinking. My name is Jeffrey. This is our fifth and final video on the use of jump in teaching and learning descriptive statistics. In this video, we'll be examining the association between two numeric variables. In this example, we'll be looking at height, a numeric variable which measures the height of a teen in inches, and weight, a numeric variable which measures the weight of a teen in pounds. While it might seem pretty intuitive that these two variables are probably positively correlated, how strong is this correlation actually? Let's take a look. First, like with all bivariate associations, we'll go to Analyze, Fit y by x. In this example, we'll put height on the x-axis and weight on the y-axis. Then we'll hit OK. This brings up a scatter plot of the association between the two variables. Since we're interested in the regression line, we'll go over to the red arrow and click Fit Line. This gives us a lot of information. Most of it is beyond what we currently need to know, so we'll close it. We'll get back to it at a later point when we examine inferential statistics. At the moment, we're really only interested in the equation for the regression line. We're also interested in correlation, however, so we'll go over to the red arrow and go all the way down to density ellipse and click 0.95. This brings up a new tab titled Correlation, and we'll open it. Here, we see the mean and standard deviation of both variables and the overall correlation for the association. In addition, in the graph, we'll notice that there's a new density ellipse, which encompasses approximately 95% of the data in the scatter plot. If you recall correctly, in a normal distribution, 95% of the data falls within 2 standard deviations of the mean. The ellipse encompasses approximately 2 standard deviations about the standard deviation line. Now let's take a look at their scatter plot. Based on the scatter plot, regression line, and correlation, we can see a moderately strong positive association between height and weight. While a correlation of 0.58 is certainly not a correlation of 1, which would indicate a perfectly linear association between the two variables, it still suggests that height and weight share a moderate linear association. Now let's try to interpret the equation for the regression line. While the y-intercept is not really interpretable because it illustrates a negative weight, when we look at slope, it tells us that on average, for every increase in height by 1 inch, a teen increases in weight approximately 4.8 pounds. But how does this regression line differ by gender, if at all? If we want to split our scatter plot by gender, we first go to the red arrow and then click Group By. Then we select biological sex and hit OK. Now that our scatter plot is divided by gender, we'll need to regraph our regression lines. Now we have the 2 additional regression lines, one for males and one for females. However, our scatter plot looks really clustered with all the old stuff, so we're going to hide the old linear regression line by clicking this arrow and unchecking the line and its report. And we'll do the same with the density ellipse. Now we just have our 2 new regression lines and their information. Once again though, a lot of this information is extraneous, and we don't really have much use for it, so we'll hide it. All we really need are the equations for the 2 regression lines. Now let's compare our 2 new regression lines. The regression line for females has a greater y-intercept than the regression line for males. However, the regression line for males has a greater slope than the regression line for females. We can see this in the scatter plot in the corresponding lines. This tells us that at lower heights, females generally weigh more than males at the same height. However, at higher heights, males, on average, weigh more than females of the same height. Well, that concludes the descriptive statistics portion of our course. Thank you for following along with my videos. I hope you've enjoyed learning about the longitudinal study of adolescent health and look forward to exploring it further on your own or with students. We hope that you'll join us for the next installment of our course, Teaching Statistical Thinking Probability. Until then, happy statistical thinking.